Good morning, students. So today's class we are going to study about the design of FIR filter using frequency sampling method. So the design procedure, let us study the design procedure. The first step is you have to choose the desired frequency response H3 of e power j omega. So that means it is a low pass filter or high pass filter frequency response or band pass or band stop. So you can choose the desired frequency response. Next step is you have to apply the sampling process. So the sample the h3 of e power j omega at n points by substituting omega equal to omega k equal to 2 pi k by n. So in that case, we will be obtaining h of k equal to h3 of e power j omega where omega equal to 2 pi k by n. So in the h3 of e power j omega, you have omega expression. In the place of omega, you have to substitute 2 pi k by n where k varies between 0 to n minus 1. Then you have to compute the n samples of impulse response h of n using the following equations. There are two different equations for n odd and n even. For n odd, the impulse response is h of n equal to 1 by n, h of 0 plus 2 into summation k equal to 1 to n minus 1 by 2, the real part of h bar of k e power j 2 pi n k by n. For n even, the formula is h of n equal to 1 by n, h of 0 plus twice summation k equal to 1 to n by 2 minus 1, the real part of h of k e power j 2 pi k n by n, k by n. So Re is nothing but the real part. So next you have to take this transform of impulse response h of n to get the filter transfer function h of z. So h of z equal to summation n equal to 0 to n minus 1 h of n z power minus n. Now let us solve a problem based on this. The given problem is you have to determine the linear phase FIR filter of length n equal to 15 which has a symmetric unit samples response and frequency response that satisfies the condition h of 2 pi k by 15 equal to 1 for k varies between 0 to 3, 0.4 for k equal to 4, 0 for k equal to 5, 6, 7. For a linear phase FIR function, theta of omega equal to minus alpha omega, where alpha equal to n minus 1 by 2. And n equal to 15, when you substitute capital N equal to 15, alpha is equal to 15 minus 1 divided by 2. So when you substitute 50 n equal to 15 here, the alpha value you will be getting it as 7 and omega equal to omega k. So in the 2 pi k by n, so in the place of n you substitute 15, so it will be 2 pi k by 15. So according to the type 1 design, so omega value we have obtained as 2 pi k by 15, alpha value we have obtained it as 7. So now according to the given problem, the first step is h of k equal to h3 of e power j e power h3 of omega or h3 of e power j omega where omega equal to omega k. So in this place we have 1 into e power minus j alpha omega k. So in the place of alpha we will be substituting 7. In the place of omega k we will be substituting 2 pi k by 15 and k value 0 to 3 and for k equal to 4 it is 0.4 into e power minus j alpha omega k and for k equal to 5, 6, 7 it is 0. So we will be getting this expression. Then h of n is 1 by n h of 0 plus twice of k equal to 1 to n minus 1 by 2, the real part of h of k e power j 2 pi n k by n. Now the next step is, in this step when you substitute 1 by 15 h of 0 plus twice into k equal to 1 to 3 real part of h of k e power j 2 pi k by 2 pi n k by 15 plus 2 into real part of, for 1 to 3 we have split, then for 4 it is this expression. So after that we have to 1 by 15, 1 plus h of 0 is 1, 2 into summation k equal to 1 to 3, the real part of h of k is e power minus 7 into 2 pi k by 15 into e power j 2 pi n k by 15 plus 2 into real part of, in this place when you substitute h of 4 as 0.4 and you will be getting this expression. Now in this you can rearrange it as the real part of e power j 2 pi k by 15 of n minus 7. So here also we can rearrange e power j 8 pi by 15 n minus 7. So now the real part of this e power term is cos. So that's why it is given cos of 2 pi k by 15. Here also it is cos of 8 pi by 15. So now when you substitute the k value 1, 2, 3, k equal to 1, 2, 3, etc., you will be getting this equation. So now in this equation, for n equal to 15, n minus 1 is 4, n minus 1 by 2 is 7. So in this equation, we have to substitute n equal to 0, n equal to 1, 2, 3, 4 like that. So we will be getting for n equal to 0 as minus 0.0141, n equal to 1 minus 0.0019. For 2 it is 0.04, n equal to 3 0.0122, n equal to 4 minus 0.09, n equal to 5 minus 0.0181, n equal to 6 0.3130. For n equal to 7 it is 0.52. So similarly, we will be finding out for n equal to 8 to 14. Then we have to find out the transfer function of the filter, which is given by summation n equal to 0 to 14 h of n z power minus n. So you have to expand this. If you expand, you will be expanding like this and substitute the symmetrical condition h of n minus 1 minus n equal to h of n. So if you apply the symmetry